Hello, and welcome to tonight's Space Sleep Story. If you appreciate what we do here, please like or subscribe for future relaxing nighttime space journeys. Tonight, we trace 5,000 years of humanity's evolving understanding of Venus, from ancient Babylonian tablets to spacecraft missions. The brilliant morning star and evening star that captivated ancient observers slowly revealed itself as the most hostile world in the inner solar system. So settle into your most comfortable position, close your eyes, and prepare for a journey through history. Before we begin, let us prepare your body and mind with gentle breathing. Take a slow, deep breath with me now. Inhale gently for 4 counts. Hold the peace. Exhale for 6. Feel your body releasing into stillness. Notice how your chest rises and falls with each breath. Let the rhythm calm your mind. With each exhale, you sink deeper into relaxation. Another gentle breath as we continue our preparation. This time, notice how the air flows through your body, bringing calm with each inhale, releasing tension with each exhale. Let my voice be your guide. Hold this peaceful moment. Feel the stress of the day leaving your body. With each breath, you release a little more into relaxation. Your body becomes heavier, warmer, more comfortable. Perfect. Now we begin. Since our ancestors first looked upward, one celestial object has dominated the twilight sky. Venus appears brighter than any star, brighter than any planet, except the Sun and Moon. At peak brilliance, Venus reaches apparent magnitude -4.6, bright enough to cast faint shadows on Earth's surface. Ancient observers saw this brilliant wanderer appear as morning star before sunrise, then as evening star after sunset. For millennia, what lay beneath that brilliant light remained utterly mysterious. Tonight, we trace how each generation peeled back one more layer of Venus's secrets. The Babylonians tracked Venus obsessively. Cuneiform tablets dating to 1600 BCE record Venus appearances over 21 years. The Amisaduqa tablet notes 8-year cycles, morning and evening star transitions, maximum brilliance periods. They used Venus positions for omens, predicting war weather and the king's fate. Ancient astronomers recognized patterns. Venus's synodic period averages 583.92 days, nearly 19 months from one configuration back to the same configuration. This precision required generations of patient observation. The ancient Sumerians initially believed the morning star and evening star were 2 separate objects. They called both Dilbat, but thought dawn's bright herald and dusk's follower were different celestial beings. Recognition that a single object appeared in both positions required tracking Venus across its inferior conjunction when it disappears into solar glare for weeks. Babylonian astronomers achieved this understanding before 1500 BCE. Imagine the insight required to connect appearances separated by months to realize one wanderer made this celestial journey. Greeks inherited Babylonian astronomical knowledge. They initially called morning Venus Phosphorus, meaning light-bearer, and evening Venus Hesperus, meaning western one. Pythagoras, around 500 BCE, recognized these as a single object. This synthesis of observation and reasoning demonstrated Greek astronomical sophistication. Venus never appears far from the Sun, reaching maximum elongation of 47 degrees. As evening star, Venus follows the Sun to western horizon. As morning star, Venus heralds dawn, rising before sunrise. Ancient observers charted these patterns without understanding the geometry that created them. The Maya civilization tracked Venus with extraordinary precision. Their synodic period measurement, 584 days, matched modern calculations within hours. They recognized that 5 Venus cycles equal 8 Earth years. 5 times 584 equals 2,920 days. 8 times 365 equals 2,920 days. The Dresden Codex contains sophisticated Venus tables. Maya warriors timed campaigns to Venus positions. They called Venus No-Ek, the Great Star, and organized ritual calendars around its cycles. Romans named the planet for Venus, goddess of love and beauty. The bright, graceful motion across twilight skies suggested divine femininity. This naming persisted throughout Western astronomy, yet the association with beauty and love would prove tragically ironic. Spacecraft would eventually reveal Venus as the most hostile world in the inner solar system. But for ancient observers, Venus remained the most beautiful object in the night sky, a wandering light that inspired wonder and mythology across every culture that watched the heavens. Claudius Ptolemy's Almagest placed Venus on an epicycle between Earth and Sun. His geocentric model correctly predicted Venus would never appear far from the Sun. But Ptolemy's system could not explain why Venus appears brightest at crescent phase. This observation required heliocentric geometry. Venus appears brightest when nearest Earth between us and the Sun, showing a large crescent. Ptolemy's model was sophisticated, but fundamentally wrong. The truth waited for Nicolaus Copernicus and the telescope. For 14 centuries, Ptolemy's astronomy dominated, despite its contradictions. Copernicus published his heliocentric model in 1543, predicting Venus should show complete phase cycles. When Venus orbits beyond the Sun, Earth observers should see full phase. When Venus passes between Earth and Sun, observers should see crescent phase. This was a testable prediction, but required magnification beyond naked eye capability. The prediction waited 67 years for telescope invention. Copernicus died never knowing his Venus prediction would be spectacularly confirmed, providing crucial evidence that Earth orbits the Sun. Science sometimes requires patience, measured in generations. Galileo Galilei, turned his telescope toward Venus in 1610. Over months of observation, he watched Venus transform. At first, a small bright disk, then half illuminated, then a large crescent with horns pointing away from the sun. This progression exactly matched Copernican prediction. Venus circles the sun, not Earth. Full when far from us, crescent when near. Galileo announced his discovery in an anagram to establish priority. Published openly in 1613. The Catholic Church later condemned this finding, but Venus's phases proved beyond doubt that Ptolemy was wrong. For centuries after Galileo, astronomers attempted to measure Venus's rotation period. Giovanni Cassini, in 1667, claimed 23 hours 21 minutes, based on perceived cloud markings. Subsequent observers reported periods from 23 hours to weeks, all based on unreliable features. Venus's thick clouds reflect 75% of incident sunlight, creating a featureless, brilliant disk. Cloud features constantly change, making rotation measurements impossible through optical telescopes. Published rotation periods ranged wildly. Some assumed Earth-like rotation, others thought Venus was tidally locked. The truth remained hidden for 3 centuries. Johannes Kepler predicted Venus transits in 1629, when Venus would appear as a black dot crossing the Sun's face. He calculated transits for 1631 and 1639, but died in 1630 before observing. The 1631 transit was not visible from Europe. The 1639 transit might have gone unobserved except for a remarkable 20-year-old English astronomer named Jeremiah Horrocks. Horrocks refined Kepler's calculations and predicted the transit for December 4th, 1639. He was perhaps the only person on Earth who knew Venus would cross the Sun that afternoon. Horrocks projected the Sun's image through his telescope onto paper in his room. He watched, waiting for the predicted moment. Venus appeared, as Copernicus had predicted, a spot of unusual magnitude crossing the solar disk. Horrocks calculated Venus's distance from Earth more accurately than Kepler, achieving a significant improvement in solar system scale measurement. Tragically, Horrocks died 2 years later, at age 22. His observation represented both the triumph of prediction and the fragility of individual genius. Science builds on such moments of solitary insight. Russian scientist Mikhail Lomonosov observed the Venus transit of 1761 from St. Petersburg. As Venus approached the Sun's limb, he noticed something extraordinary. A luminous arc appeared around Venus's dark disk before it touched the Sun's edge. Lomonosov correctly interpreted this as atmospheric refraction, light from the Sun bending through a substantial atmosphere surrounding Venus. This was the first detection of atmosphere on another world. The discovery remained little known in the West for decades, but Lomonosov had glimpsed Venus's most dominant feature, the crushing carbon dioxide atmosphere. Edmund Halley proposed using Venus transits to measure solar parallax, and thus the Sun's distance from Earth. Observers stationed at widely separated locations, timing transit contacts, could triangulate solar system scale. This required international coordination unprecedented in science. The 1761 transit saw over 120 observers at 62 stations worldwide. French astronomers traveled to India, Austrians to Siberia, British to St. Helena. Results varied widely due to an optical effect called the black drop, where Venus's edge appears to stretch toward the Sun's limb. Precise timing proved impossible. The Royal Society sponsored HMS Endeavour's voyage to Tahiti for the 1769 transit. Captain James Cook and astronomer Charles Green observed from Point Venus under perfect conditions. Venus appeared as a black circle on the Sun's face. But at ingress and egress, the black drop effect defeated precise timing. Venus's edge seemed to elongate, like ink spreading on paper. Despite sailing 10,000 miles and months of preparation, nature presented an optical phenomenon they could not overcome. They calculated solar parallax within 10% of the true value. The expedition became more famous for Cook's subsequent Pacific explorations. Transits of 1874 and 1882 applied photographic techniques for the first time. Expeditions scattered worldwide captured images showing Venus's silhouette against the Sun. Photographs confirmed the black drop effect was real, not observational error. These were the final 19th century opportunities. The next transit would not occur until 2004, a gap of 122 years. By then, astronomers would know Venus through radar and spacecraft. The transit observations that consumed centuries of effort would become historical curiosities. Progress rendered the method obsolete. Early 20th century spectroscopy attempted to detect water vapor and oxygen in Venus's atmosphere. All attempts failed. Clouds reflected sunlight before atmospheric gases could be adequately measured. Some scientists suggested Venus might be Earth-like beneath the clouds. Science fiction writers imagined jungle worlds and swamp creatures. Venus as Earth's twin became popular mythology. But in 1932, everything changed. Walter Adams and Theodore Dunham at Mount Wilson Observatory used infrared spectroscopy. They detected strong carbon dioxide absorption bands. Venus's atmosphere was fundamentally alien. The romantic vision began to die. Rupert Wilt proposed greenhouse effect calculations in the 1940s. He suggested carbon dioxide could trap solar radiation, creating extreme surface temperatures. His calculations indicated 400 degrees Celsius was possible, hot enough to melt lead. Critics called this extreme. Venus, as potentially habitable world, persisted in public imagination. Even as evidence mounted, some refused to abandon the idea of Venusian life. The 1950s contactee movement claimed meetings with benevolent Venusians. Science and fantasy collided. Spacecraft would soon settle the question definitively. In 1961, JPL's Goldstone antenna pointed toward Venus and bounced radar signals off the cloud-shrouded world. Doppler analysis of reflected signals revealed rotation. But the period shocked astronomers. Not 23 hours, as Cassini claimed. Not even close. 243 Earth days. Venus rotates once every 243 days longer than Venus's 225-day year. One Venus day exceeds one Venus year. And the rotation was retrograde, backwards compared to other planets. 3 centuries of astronomical observations were wrong. One radar measurement rewrote textbooks. Mariner 2 launched toward Venus in 1962. On December 14th, it flew within 35,000 kilometers. The spacecraft's microwave radiometer measured surface temperature, 462 degrees Celsius on both day and night sides. Lead-melting heat. Mariner 2 detected no magnetic field, measured solar-wind interaction, proved interplanetary missions were feasible. But most importantly, it ended all speculation about habitable Venus. The goddess of love was a hellscape. Romantic Venus died on December 14th, 1962. The Soviet Union committed to comprehensive Venus exploration. The Venera program would span 2 decades. Venera 4 entered the atmosphere in October 1967. During 94 minutes of descent, it transmitted atmospheric data. 90% carbon dioxide, temperatures rising beyond predictions. At 26 kilometers altitude, communications ceased. Venus crushed the spacecraft. Pressure far exceeded design specifications. Soviet engineers had designed for 20 atmospheres. Venus showed 90. They designed for 300 degrees. Venus showed 462. Each mission taught harsh lessons. Venera 5 and 6 also failed to reach the surface, crushed by unexpected pressure. Soviet engineers redesigned for harsher conditions. Venera 7 descended on December 15, 1970. It survived landing, transmitted for 23 minutes from the surface. First spacecraft to successfully send data from another planet's surface. The signal was weak. The lander had hit hard when parachute partially failed. But for 23 minutes, humanity heard Venus speak. Temperature, 475 degrees. Pressure, 92 atmospheres. More hostile than anyone imagined. Venera 9 reached Venus orbit in October 1975. The lander separated and descended. It survived landing and transmitted the first images from another planet's surface. The panorama showed angular rocks, basalt-like terrain, flat landscape under orange-brown sky. The lander operated for 53 minutes before succumbing to heat. Venus was not molten rock, not eternal hell. A solid surface existed beneath the crushing atmosphere. Sharp rocks that had never felt rain. a landscape illuminated by diffuse orange light filtering through sulfuric acid clouds. Venera 13 descended in March 1982. It achieved the longest surface survival, 127 minutes. The lander transmitted color photographs, sharp rocks, flat terrain. A drill sampled soil for chemical analysis. Everything bathed in that strange orange glow. Each Venera mission represented thousands of Soviet engineers fighting impossible conditions, designing for environments humans had never experienced. Every landing was a triumph. Every minute of transmission, a victory against Venus's hostility. The Venera program remains one of planetary exploration's greatest achievements. Pioneer Venus Orbiter carried the first Venus orbital radar. From 1978 to 1992, it mapped 93% of the surface. Resolution was modest, 100 kilometers, but revealed major features. 2 continent-sized highlands, Ishtar Terra and Aphrodite Terra. Massive shield volcanoes. Rift valleys hidden under eternal clouds. For the first time, Venus's geology emerged from mystery. A volcanic world, not Earth's twin, a planet that had evolved down a different path. Similar size, similar composition, but utterly alien surface. NASA's Magellan spacecraft launched in 1989 from Space Shuttle Atlantis. It reached Venus orbit in 1990. Magellan carried synthetic aperture radar mapping 98% of Venus at 100 to 300 meter resolution. The mission transformed understanding. 1,560 major volcanoes, pancake domes, coronae, tesserae terrain. No impact craters smaller than 3 kilometers. Venus's thick atmosphere filters out small meteors. Surface age estimated 300 to 600 million years. Venus had been catastrophically resurfaced. Volcanic activity had erased older terrain. A world shaped by internal heat. Ground-based radar from Arecibo continued Venus mapping during favorable approaches. The powerful antenna revealed fine surface details. Scientists discovered metallic snow on highland peaks, lead sulfide and bismuth sulfide condensing from atmosphere at high elevations, chemical processes impossible on Earth. Arecibo contributed high-resolution imaging of polar regions. Every observation added detail. Venus transformed from featureless bright star to comprehensively mapped world. From mystery to knowledge. 5,000 years of observation culminating in complete surface surveys. Spectroscopic studies in 1973 finally identified Venus's clouds. Not water vapor, as some assumed. Sulfuric acid. Droplets of 75 to 96% concentration at 48 to 68 kilometers altitude. clouds that would dissolve human tissue. The clouds explained Venus's high albedo. Sulfuric acid droplets reflect light efficiently. Venus hides beneath chemical clouds that drift through carbon dioxide atmosphere. A world wrapped in acid and greenhouse gases. Beautiful from distance. Lethal up close. Carl Sagan's greenhouse effect calculations predicted extreme heating. Controversial when proposed in the 1960s. Mariner 2 confirmed Sagan was right. 462 degrees Celsius. Runaway greenhouse effect. Carbon dioxide traps solar radiation. As Venus heated, ancient oceans evaporated. Water vapor increased greenhouse warming. Surface temperature rose higher. More carbon dioxide released from rocks. Temperature spiraled upward. Venus crossed a point of no return. Climate system tipped into permanent hell. A cautionary tale. Venus and Earth formed at similar distances from the Sun. Similar size, similar composition. Yet one world became garden, the other became furnace. The difference teaches us about planetary atmospheres and climate stability. Venus received slightly more solar energy, enough to prevent oceans from persisting. Water vapor greenhouse effect began. Positive feedback loops took over. Understanding Venus helps us understand Earth's climate fragility, how feedback loops can amplify small changes, why atmospheric composition matters so profoundly. European Space Agency's Venus Express studied atmospheric dynamics from 2006 to 2014. 8 years in orbit. The mission characterized the super-rotating atmosphere. Winds circle the planet in 4 days, despite 243-day surface rotation. Atmospheric dynamics still not fully understood. Venus Express detected possible volcanic activity. Variations in sulfur dioxide suggesting active volcanism. The planet remains geologically alive. Internal heat still shaping the surface. Venus's story continues. Japan's Akatsuki spacecraft has monitored Venus weather since 2015. Studying atmospheric circulation, cloud patterns, thermal structure. Images show complex dynamics, polar vortices, equatorial jets, convection patterns in the clouds. Venus's atmosphere remains active, mysterious, challenging to model. Each observation adds understanding. The mission continues, providing data about Venus's climate system, a laboratory for understanding thick planetary atmospheres. NASA has selected 2 missions for Venus exploration in the 2030 decade. Veritas will map surface geology with advanced radar. Da Vinci Plus will drop a probe through the atmosphere, measuring composition, structure, imaging the surface during descent, perhaps sampling the atmosphere at different altitudes. These missions will continue humanity's Venus investigation, building on centuries of observation. Each generation asks new questions. Each mission reveals new mysteries. Venus still has secrets to share. From Babylonian tablets recording cycles to spacecraft landing on the surface. 5,000 years of patient observation. Each generation contributed pieces to an enormous puzzle. Ancient astronomers tracked motions. Galileo discovered phases. Transit observers attempted distance measurements. Spectroscopists revealed atmospheric composition. Radar pierced the clouds. Spacecraft survived the hellscape. Science builds across millennia. Understanding accumulates. Venus transformed from wandering star to comprehensively known world. From goddess of love to lesson in planetary evolution. The story of Venus demonstrates how human understanding evolves. Mystery to knowledge. Ancient observers saw bright beauty and assigned divine meaning. Renaissance astronomers discovered geometric reality. 20th century scientists revealed chemical and physical harshness. Each era saw Venus through its own technological and cultural lens. Each added truth. The accumulation of knowledge represents humanity's collective achievement. Patience and persistence across generations. Questions answered. New questions emerging. Consider how Venus appears in twilight. That brilliant point of light has inspired wonder for millennia. Underneath lies a world of extremes, crushing pressure, lead-melting heat, sulfuric acid clouds. Yet it orbits peacefully, following its path around the sun. 225-day year, 243-day day, rotating slowly backwards. A world of paradoxes. Venus's transformation in human understanding mirrors our own growing comprehension of the universe. From myth to mathematics, from divine interpretation to physical law, from speculation to measurement. Science as a method for revealing truth. Observation hypothesis testing. Building understanding through evidence and reason. Venus taught us this process. 5,000 years of learning how to learn. The climate lessons Venus teaches remain urgent. How greenhouse gases trap heat. How feedback loops amplify warming. How planetary climates can tip into new stable states, states that may not support life as we know it. Venus and Earth started similar. One choice of path led to garden, another to furnace. We study Venus to understand Earth, to protect our own climate, to avoid Venus's fate. Imagine standing on Venus's surface in a protective suit. Temperature hot enough to glow. Pressure 90 times Earth's sea level. Sky above orange from scattered light. Clouds invisible from below. Basalt rocks at your feet, sharp and dry. Never weathered by water. A landscape frozen in time. Resurfaced 300 million years ago. Waiting beneath eternal cloud. Soviet engineers designed Venera landers knowing they would fail quickly. Success meant minutes, not hours. Each minute of data was precious victory. Cameras that would operate in heat exceeding design limits, circuits that would melt, batteries that would cook. Yet they built them anyway, sent them across space. Venera 13 survived 127 minutes, long enough for color panoramas, long enough for soil analysis. Triumph measured in heartbeats. Magellan revealed a volcanic planet. Shield volcanoes taller than Everest. Pancake domes unique to Venus. Lava flows stretching hundreds of kilometers. Coronae where mantle plumes reach surface. All this hidden beneath clouds for eternity. Revealed by radar. Radio waves penetrating atmosphere. Bouncing off surface. Creating maps. Transforming mystery into topography. The rotation mystery persisted for 3 centuries. Cassini to Goldstone. Optical observations defeated by featureless clouds. Radar finally revealing truth. 243 days. Retrograde. Why Venus rotates backwards remains debated. Perhaps giant impact early in history. Perhaps atmospheric tidal effects. Even with comprehensive knowledge, mysteries remain. Venus still guards some secrets. Transit observations consumed centuries of effort. Expeditions to distant lands. Cook sailing to Tahiti. Astronomers in India, Siberia, St. Helena. All to time Venus's passage across the sun. Black drop effect defeated precision. Optical phenomenon they couldn't overcome. Yet the effort advanced astronomy. International cooperation, refined calculations. Each attempt added knowledge. Galileo's phase observations required courage. Publishing evidence against geocentric model. Catholic Church condemned heliocentric theory. Yet Venus's phases proved Copernicus right. No geocentric model could explain them. Science sometimes requires standing against authority, trusting observation over doctrine. Galileo watched Venus transform from disk to crescent, proof that Earth was not the center. Truth revealed through patient observation. Ancient Babylonians recorded Venus cycles without understanding orbital mechanics. Pattern without theory. Maya calculated synodic period precisely. 5 Venus cycles equal 8 Earth years. Mathematical relationship observed and recorded. Understanding deepened over millennia, from pattern recognition to geometric models, from models to physical law. Each civilization built on previous knowledge. Human understanding as collaborative achievement. Lomonosov saw atmospheric refraction during transit. Arc of light around Venus's limb. First detection of atmosphere beyond Earth. Insight from a single observation. Correctly interpreted. Discovery little known in the West initially, yet Lomonosov had glimpsed fundamental truth. Venus wrapped in substantial atmosphere. Air on another world. Possibilities of other skies, other weathers. Spectroscopy revealed carbon dioxide in 1932. Strong absorption bands. Adams and Dunham changed Venus understanding overnight. Not Earth-like atmosphere. Alien chemistry. Romantic Venus began dying that day. Jungle worlds and swamp creatures faded. Reality replaced fantasy. Science revealing truth, even when truth disappoints imagination. Mariner 2 flyby marked a turning point. First successful planetary mission. December 14th, 1962. Temperature measurements ending speculation. 462 degrees. Hell world confirmed. Lead melting heat. Yet also proof that interplanetary missions were possible. Spacecraft could survive journey. Instruments could measure alien worlds. The space age truly beginning. Venus Express watched atmospheric superrotation. 4-day winds circling the planet. Surface rotates once in 243 days. Atmosphere decoupled from surface, racing around the planet independently. Mechanism still not fully understood. Atmospheric dynamics challenging to model. Venus's thick atmosphere behaves unlike Earth's. Different physics, different patterns. Alien meteorology. Volcanic resurfacing 300 to 600 million years ago. Catastrophic event. Perhaps the entire surface melted. Planetary scale volcanism. old terrain erased. Since then, volcanic activity continues, slowly modifying the landscape. Venus remains geologically active, internal heat driving surface change. A living planet in that sense. Sulfuric acid clouds drift at 50 kilometers altitude. 75 to 96% concentration. Droplets that would dissolve human tissue. Yet they create Venus's brightness, reflecting sunlight efficiently. Beauty built from corrosive chemistry. Brilliant appearance hiding hostile reality. Venus's clouds remain dynamic, forming, circulating, raining acid that evaporates before reaching surface. Arecibo radar detected metallic snow on highland peaks. Chemical impossibility on Earth. Lead sulfide and bismuth sulfide, condensing at high elevations where temperatures are marginally cooler. 450 degrees instead of 462. Alien chemistry creating alien weather. Metal condensation. Every Venus discovery reveals strangeness. Familiar elements behaving unfamiliarly. Physics at extreme conditions. Pancake domes, unique to Venus. Volcanic features found nowhere else. Viscous lava erupting onto surface, spreading into circular mounds. Flat tops suggesting liquid lava pools. Unique geology emerging from unique conditions. High pressure affecting lava behavior. Venus as laboratory for volcanic processes. Different gravity, different atmosphere, different results. Coronae mark where mantle plumes reach surface. Circular features hundreds of kilometers across. Hot material rising from deep interior, deforming the crust, creating distinctive patterns. Tectonic processes different from Earth. No plate tectonics. Instead, localized upwelling. Venus's interior heat escapes differently. Volcanic hotspots, mantle convection, unique planetary evolution. Tesserae terrain shows complex deformation, intersecting ridges and valleys, highly fractured ancient crust, perhaps surviving from before resurfacing. Oldest terrain on Venus. Tesserae cover perhaps 8% of surface. Islands of old crust in sea of younger volcanics. Geological history written in terrain. Read by radar. Interpreted by planetary scientists. No impact craters smaller than 3 kilometers. Atmospheric filtering. Small meteors burn up during entry. 92 atmospheres of pressure. Dense carbon dioxide atmosphere. Only largest impactors reach surface intact. Crater population reveals surface age. Counting craters like counting time. Fewer craters mean younger surface. Venus resurfaced recently in geological terms. Planned Veritas mission will improve radar mapping. Higher resolution than Magellan. Advanced synthetic aperture radar. Better topography. Better compositional data. Building on Magellan's foundation. Next generation technology. Each mission asks deeper questions. Each reveals finer details. Progressive understanding. Da Vinci Plus will drop through atmosphere, measuring composition at different altitudes. Noble gas ratios revealing formation history. Isotope measurements. Climate evolution clues. Perhaps imaging surface during descent. New perspectives on familiar world. Venus investigation continues. Building knowledge, decade by decade. Century by century. Millennium by millennium. "5,000 years from first observations. Still learning. Still discovering. Still being surprised. Venus teaches patience. Mystery yields slowly. Understanding accumulates across generations, each adding their piece. Science as human endeavor, collective achievement. ancient astronomers would marvel at our knowledge. Surface maps, atmospheric composition, temperature measurements, rotation period. Yet they laid the foundation. Patient observation, careful record-keeping. Their cycles and tables made later discoveries possible. We stand on their shoulders, looking deeper, understanding more. Venus in evening sky tonight appears much as it did to Babylonians. Same brilliant light, same graceful motion, same beauty. But now we know what lies beneath. Hell world wrapped in clouds. Knowledge transforms perception. Beauty remains, but meaning deepens. Mystery replaced by understanding. The goddess of love, revealed as a world of extremes. Irony in the naming, or perhaps appropriateness. Love can burn. Venus burns. 462 degrees. Hot enough to melt lead. Hot enough to glow. Passion literalized. Beauty hiding fire. Runaway greenhouse effect. Point of no return. Climate tipping. Feedback loops. Irreversible change. Venus crossed that threshold. Lost its oceans. Lesson for Earth. Warning written in another world's fate. Atmospheric composition matters. Climate stability precious. Tonight, as you drift toward sleep, Venus orbits peacefully, following eternal path. 225 days per orbit. Unchanging motion. Reliable pattern. Cosmos ordered. Predictable. Comprehensible. Beautiful. Science reveals nature's secrets. Patience and persistence. Observation. Measurement. Theory. Building understanding. Generation by generation. Human achievement, collective knowledge, shared discovery. Rest now. Venus continues its journey. Ancient cycles, modern understanding. Mystery transformed, beauty revealed, knowledge accumulated, wonder preserved. Floating peacefully through space, through time, through understanding. Sleep gently, dream of distant worlds. Venus shines. Brilliant light. Ancient beauty. Modern knowledge. Orbiting eternally, following path. Clouds drift. Sulfuric silence. Venus waits. Hot world, cold space. Balance. Rotating slowly, backwards. Different rhythm. Surface unseen. Radar knows. Hidden truth. Ancient watchers. Modern spacecraft. Same sky. 1,000 years. Still learning. Patience. Babylonian tablets. Silicon memory. Recording Venus. Goddess transformed. Planet revealed. Knowledge. Transit shadow. Crossing sun. Rare moment. Galileo watching. Phases changing. Proof. Venera landing. Brief survival. Victory. Magellan mapping. Radar eyes. Seeing. climate lesson. Greenhouse warning. Wisdom. Evening star. Morning star. One world. Brilliant beauty. Hidden hell. Paradox. Understanding grows. Mystery remains. Balance. Venus waits. Eternal orbit. Peaceful. Sleep now. Dream softly. Rest. Floating, drifting, peace. Stillness. quiet, rest. Venus, shining beauty. Night, peace, sleep. Darkness, comfort, safe. Stars, eternal, watching. Breath, slow, calm. Quiet, deep, still. drifting softly down. Warmth, gentle, safe. Release. Let go. Rest. Peaceful night. Sleep. Distant stars shine. Silence. Pure peace. Breathing. Easy. Slow. Venus, glowing, far. Dreams, come now. Soft night rest. Deep peace, sleep. Still, calm, safe. rest. Now, sleep. Peace, deep sleep. Sleep, sleep, sleep. Sleep, sleep. Sleep.